Hello guys, this is Dr. Edwards again. Let me give you here my suggested solution to some of the exercise problems in Chapter 12. Okay, so let me get started. Number one, what aspect of Leo Voisy work marked the beginning of chemistry as a science? Lavoisier was a strong advocate of making measurements, weighing the value, finding the masses of quantities that were being used in reactions. Therefore, in simple words, what aspect? The aspect is the advocacy of making measurements, number one. Number two, what is the formula of ozone? And B, ozone in the atmosphere is both harmful to and essential for our health. Explain. The chemical formula for oxygen is O sub 2. For ozone is O sub 3. Just that simple. In the upper atmosphere, actually in the stratosphere, ozone is very useful there because it absorbs ultraviolet radiation and prevents that radiation from reaching ground level where we live. So ozone is needed badly or greatly in the upper atmosphere. We must have it. However, in the lower atmosphere, down at ground level, smoke and smog often has ozone within it, and ozone leads to upper respiratory illnesses. So at ground level, we do not want ozone. It leads to upper respiratory illness. In the upper atmosphere, it's absolutely needed. Number three, what role does air play in combustion? Air is absolutely necessary for providing the oxygen in combustion. Without oxygen, no combustion. So you must have it. Okay? Number four, for a given amount of energy to be used for its propulsion, a spacecraft must have larger tanks than an airplane. Why? A spacecraft is meant to travel beyond the Earth's atmosphere, which means it must take its oxidizer, its fuel with it in a tank. Whereas an airplane flies within the Earth's atmosphere where there's plenty of oxygen, therefore it doesn't need as many tanks or as larger tanks to carry just its fuel. So an airplane carries just its fuel, a spacecraft must carry its fuel and oxygen as the oxidizer. Number six, when hydrogen is burnt in oxygen, water is formed according to the reaction 2H2 plus 1O2 yields 2H2. How many moles of H2 and how many moles of O2 are needed to produce 3 moles of water? Well, what you do, you start with the given equation here, that 2H2, so this means 2 moles of H2 plus 1 mole of O2 yields 2 moles of H2O. Okay, so you have this ratio opportunity. So from this equation, we see that the coefficients mean that 2 moles of H2 yields as the product 2 moles of water. 2 moles here, 2 moles there. Thus, the simple ratio analysis indicate, I'm going to use X for the unknown. So X moles of H2 to 2 moles of H2 will yield 3 moles of H2O compared to 2 moles of H2O. Whereas now X is the unknown, 3 is what I wish to have. Therefore, this ratio is valid. Solving the ratio for the X moles of hydrogen yields, go through the mathematics, 2 times 3/2, it yields 3 moles of H2. In a similar manner, we ask the question, we ask how many moles of O2 is needed. Once again, you come back to this formula and you compare. We have 1 mole of oxygen yields 2 moles of H2O. So you have 1 to 2 ratio. So here it is then. So I'm using X again as the unknown. X moles of O2 to 1 mole of O2O to O2 yields then 3 moles of H2O, which is what I wish to have, compared to 2 moles of H2O. Solve this mathematics, and we get the value 3/2. So it's 1.5 moles of oxygen. Hold on, let me go to the next problem. So I want you to know just a little bit about these moles. How many moles of propane, and propane is C3H8, can be prepared from 1 mole of carbon, first question, or from 1 mole of hydrogen, second question? Let me do the first question firstly. So the given formula is C3H8. The only way you can ever get that is somehow you must have had 3 moles of carbon in the beginning on the reaction side. So 1 mole of carbon will yield 1 mole of, put a 1 in front of this C3H8, will yield 1 mole of C3H8. Therefore, if only 1 mole of carbon is used, then only 1/3 of C3H8 can be produced. We don't have enough carbon to yield 1 complete mole of C3H2. Therefore, the answer is 1/3 mole of propane, C3H8 in this case. Okay, let me go to the next one. Also, C3H8 indicate that 8 moles of carbon are needed to produce 1 mole of C3H8. Thus, if only 1 mole of hydrogen is used, then only 1/8 of C3H8 can be produced. You can't produce more on the right-hand side of the equation than you start with on the left-hand side. And these coefficients indicate what we can have. And in this case, the subscripts also. Thus, the answer is 1H mole of propane in this case. Let me go to the next question. Question 27. Which of the following are exothermic reaction and which are endothermic? I want you to know, as we've already said and illustrated in my previous videos and other information that's available for you, all exothermic reaction are those that liberate energy. So on the right-hand side, as products, the E is there as liberation of heat. But for endothermic reaction, energy must be put into the process in order to drive the reaction to occur. So therefore, an explosion. The explosion of dynamite. The explosion of dynamite release energy as heat, sound, etc., etc. Light as well. Thus, but mainly heat is this question. Thus, the explosion is an exothermic process, an exothermic reaction. The burning of methane release energy as heat. Thus, burning is an exothermic process. Number B in this particular number. C, the decomposition of water into its elements. That is to say, You can break water, and this is a balance equation. 2 moles of H2O plus energy will break down water into, or decompose water into 2 moles of hydrogen gas and 1 mole of oxygen gas. Therefore, the decomposition of water is an endothermic reaction. For D, this dissociation of water into its ions. So as you know, from the previous chapter, we've already studied that water plus energy can break water down or decompose it or dissociate it into the OH ion plus the hydrogen ion, or the hydrogen ion. And this then is an endothermic process. The burning of iron in chlorine. So this is the balance equation for that. 2 moles of iron plus 3 moles of chlorine gas yields 2 moles of iron chloride or ferric chloride plus energy is released. This is an exothermic process here. And lastly, the combination of zinc and sulfur to form zinc sulfide. This is the equation with the release of energy. So this is an exothermic process. Finally, the 48, a displacement reaction is an oxidation reduction reaction in which one element displaces another from solution. In each of the following displacement reaction, identify the element that is oxidized and the element that is reduced. Always, the element that is oxidized loses electrons in the process, and the element that is reduced gain electrons. You can't have one without the other. As something loses electron, something else has to receive or gain that electron. So in this displacement process, you see that sulfur exists in the beginning. In the not sulfur, zinc exists initially, and copper exists finally in the solution. So here we have zinc, and then this is zinc 2 plus. And here you have copper 2 plus, and you have copper. So what we have, copper gains electrons. That's the only way you can go from copper 2 plus to pure copper. And zinc lose electrons. You start with zinc, and then you end up with zinc 2 plus. So zinc has lost electrons. Therefore, copper is reduced and zinc is oxidized. That's the pattern that you need to have. Here we have iron plus 2 hydrogen ions yield then iron 2 plus and hydrogen gas. So here we have the hydrogen iron gains electrons because now we've come from the hydrogen iron to the hydrogen gas, and the iron Fe has lost electrons. Thus, H plus 1 is reduced and the iron is oxidized. Now for the last one, chlorine gas plus bromide will yield chlorine ions and the bromide gas. What has happened here? Chlorine gain electrons and bromide lose electrons. Thus, chlorine is reduced and bromide is oxidized. Okay? So just wanted to share that with you. I hope this helps a little bit, okay? Bye-bye now.